Alright, hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. Before we get started today, pretty simple thing we gotta do today. It's a little bit of busy work, but we're just replacing Printf so that we can have that so that we're not relying on the C runtime library for it. Couple things I wanted to mention. One is that I'm going to tweet out soon about it, but the early registration for Handmade Con will be ending soon, I believe. We're getting to the point where the speaker list will probably start getting finalized, and so if you haven't bought tickets to Handmade Con and you know you want to go already, definitely make sure you grab those before the better price goes up. I know most people always say that the ticket price is not really important because traveling to Handmade Con always costs more than the ticket price, which is what we work hard to do. We try to keep ticket prices as low as possible, but I mean, you might as well save $20 if you know you're going to. If you don't know whether you're going to go, then don't worry about it. Hey, it's only $20, I guess is the converse, and you can wait till closer to the event. But just thought I'd point that out. That's one thing. And the second thing is I will be speaking at this conference. Point that out. That's one thing. Just thought I'd point that out the event, but just thought I'd point that out. That's one thing. And the second thing is I will be speaking at this conference. They asked me to come and speak at it, and generally, you know, I try to support any conference that seems to be run, ethically and for the benefit of the public. And this, they asked me if I would give a talk here, and it definitely looked like the kind of conference that's really for the benefit of the public, and so I was down with that. I don't know very much about it other than the fact that they're a group that does basically research paper review kinds of speeches. These are the speakers who are speaking at it, but it's actually part of a bigger, very strange conference. I have no idea, like, this conference was purely bizarre. I had never heard of it, but I looked and I was like, it looked like one of those like Kafka-esque things where you're like, what is happening? Because I looked at like the names of the presentations, and they're like kind of hilarious, right? Like things that are just, I look at them and I'm like, it's all like stuff that I don't understand how you would need a presentation about. They're so bizarre. But, or they're just like kind of off in crazy town about like, things that I don't even know. Like, but anyway, point being, the conference is crazy. I have no idea what the deal is with it, but it looks like it's fairly sizable and popular. And I guess all you really have to do is you register for the whole thing. I don't even know. Point being, if you happen to be going to this thing and going to this crazy conference, this Papers We Love conference is like a one-day thing that happens before it. And I will be speaking at it, so if you want to go to that, there is that information. And I just don't even know what this is. I could not tell. I have no idea. It was very strange. And so I just kind of closed it and was like, well, all right. So anyway, but the Papers We Love thing is kind of cool, and if you look too, they have a Papers We Love Twitter feed that's kind of cool too, if it's the sort of thing that you're into. Couple things I wanted to mention. One is that I'm going to tweet out soon about it, but the early registration for Handmade Con will be ending soon, I believe. We're getting to the point where the speaker list will probably start getting finalized, and so if you haven't bought tickets to Handmade Con and you know you want to go already, definitely make sure you grab those before the better price goes up. I know most people always say that the ticket price is not really important because traveling to Handmade Con always costs more than the ticket price, which is what we work hard to do. We try to keep ticket prices as low as possible, but I mean, you might as well save $20 if you know you're going to. If you don't know whether you're going to go, then don't worry about it. And the second thing is I will be speaking at this conference. They thing that you're into, but they basically, tweet out, little presentations that people do about various papers that have come out recently. And I guess the main thing that's probably a little problematic for a game person is they tend to not be super game centric, but it's kind of cool anyway, like just in terms of, keeping abreast of like what's going on research-wise is kind of fun. It would be neat if there was a game version of this. Maybe there is, I don't know, but it would be kind of cool for someone to have a feed where it's just like, hey, papers that are sort of thing that you're into, but they basically, tweet out cool. And if you look to, they have a papers we love thing. It's kind of cool. And if you anyway, but the paper, so all right. I was like, well, all right. So anyway, but the papers we love thing is kind of cool. And if you look to, they have a papers we love Twitter feed that's kind of cool too. If it's the sort of thing that you're into, but they basically, tweet out, little presentations that people do about various papers that have come out recently. And I guess the main thing that's probably a little problematic for a game person is they tend to not be super game centric, but it's kind of cool anyway, like just in terms of keeping abreast of like what's going on research-wise is kind of fun. It would be neat if there was a game version of this. Maybe there is, I don't know, but it would be kind of cool for someone to have a feed where it's just like, hey, papers that are sort of relevant, to games, and you could just subscribe and kind of see them as they come up. Anyway, that's it for the business, if that makes sense. I'm going to go ahead and for the business, if that. Anyway, that's it for the business. If that makes sense. But they basically, Anyway, that's it for the business, if that makes sense. I'm going to go ahead and get started on the actual, or I could just launch the Intel Architecture Guide because, that's always good. I'm going to go ahead and get started. It's day 327, so go ahead and use day 326's source code when you get a chance. And I am going to go ahead and go back to doing the printf. If you remember where we left off, we essentially implemented a little scanner because we just started this at the end of the stream last time. But basically, we replaced printf with a call to our own function, and we did a little scanner. But all it does, source code when you get a chance. And I am going to go ahead and go back to doing the printf. If you remember where we left off, we essentially implemented a little scanner because we just started this at the end of the stream last time. But basically, we replaced printf with a call to our own function, and we did a little scanner. But all it does is it essentially just prints out what the format codes would have been. But it doesn't actually do anything, right? So all you see is just what the format string is. I mean, minus the %, which we stripped out. So our goal is essentially to go from just the format strings to actually printing things out. And like I said, that probably won't be too hard for us to do in relatively short order. Except for floating point printout. Floating point printout is traditionally extremely difficult. If you don't believe me, just see the trail of papers of people trying to implement floating point printout. Lucky for us, and I mentioned this on the previous stream, I do know that someone recently printed a paper that actually. I do know that someone recently, and I mentioned this on the previous stream. Lucky for us, and I mentioned this on the previous stream, I do know that someone recently printed a paper that actually supposedly has a much cleaner and easier way to implement floating point printout. So hopefully we can go lean on that, and maybe it really is much easier to do now. But up until that, it was definitely the case that people struggled with it You know, if you looked at what some of the standard papers were before on how to print out a floating point number, they're pretty crazy. Let me see if I can find one from the old days. Let's see. Dragon 4, I think, is the one that I was thinking of. Let's see if we've got it here. But you can see, I mean, just even looking at the code, it's kind of crazy. But just in terms of how easy it is, I don't know, is that the one I'm thinking of? I want the paper, is what I want. Is this the one? No, this is the new one. The one that I actually want to use. But I thought there was kind of a... I thought there was kind of an older one here. This might be it. No. All right. Anyway, not worth rat-holing on. Point being, if you want to spend some time going down that particular rat hole yourself, you can go look at, for example, you could just open up that paper. That's the new paper that is the one that I wanted to take a look at, and go read through its references and find the old ways of printing them out. And it's just kind of crazy how, you know, convoluted it was and how obtuse of a problem it apparently was. It's not a problem I've ever looked at myself. I don't know if maybe people are making a mountain out of a molehill or something, but point being, lots of people have kind of flailed at it and it didn't go well. So that is really the only part that requires any special care, is the floating point part. Everything else is actually just kind of a bookkeeping. Since we don't have any concerns, we're not using user input values here or anything like that. We don't even really have security concerns in this case. It's a lot easier we can be sloppy if we want to be sloppy on this sort of thing, and it's not going to be a problem for us. So that's also kind of a handy sort of a bit there. So I don't know where I put this thing. I'll admit that, but I think it was down here, and okay, so it is. So here's our function that we wrote that's kind of set up for us to start implementing our printf. You can see that it's format string list. You remember we talked about the arg list part for variable length argument lists, because you know how that printf tends to be implemented as a variable argument list. If you don't understand how those work, go back and watch the previous stream, because I explain how that sort of stuff works. So at this point, what we need to do is start actually processing these percentages and handling them properly. So as you can see, what happens here, we come through and we've got our sort of our destination output little utility that we have here. And we're looping over the input, and every time we see a percentage sign, right now we're just skipping it. But if we don't see a percent sign, then we're actually outputting it. So what we need to do now is implement something that actually does work on the percent sign. Now, I'm going to do something very simple first, and then we'll sort of expand it out, because we've actually got a lot of things we have to handle if we want to sort of have a printf that does the stuff that we need to do, because we have stuff like 0, 2 and stuff like that, like you know, width specifiers and pad with 0 and those sorts of things. So in order to support those properly, we have to do some additional work besides just looking at one character after the percent and printing out the thing that it's indicating. But, for example, when we get the percent sign, what I could do here is say, well, okay, if the thing that I'm looking at now after the percent sign is an S, for example, let's just take a look at how we would implement one easy printout type. Okay, so if it's an S, then I want to look at the S string value, basically. And what I know that I can do, because we talked about this before, is once I have an arg list, I can pull things off of the arg list. Now, if you remember, I kind of showed you what those functions look like over here. I'm just going to bring them up again so you can look at them while I'm doing this. Well, I don't want VA start, but I want VA arg. Well, I don't want VA start, but I want VA arg. So if I go to the definition of that, you can see it's kind of circuitously defined here, but we can just drill down. You can see how it goes, right? It's just looking up into the stack to find whatever the argument is that I tell it, and I'm going to pass it this t, and the t value is just the type that I think should be on the stack at the current location, right? And it's going to pop that guy, basically, it will not really pop it off the stack, but it's going to like advance its sort of idea. The VA list is sort of a pointer, right, to where on the stack we're reading from. It's going to move that forward, or in, forward or backwards, depending on how your compiler decides to do it, but it's going to move it in the correct direction for advancement, we'll put it that way. It's going to move it by the size of that type. So if I tell it I want to read a char star, it's going to go forwards by like 8 bytes on the 64-bit architecture, right? And it's going to give me back the value that's in that location. So that's what I need to do. So if I see an S, then I know, well, okay, I've got an arg list, and I need to read a char star because I'm expecting the argument to be a char star. So this is like the string pointer, right? And now that I have that string pointer, I'm of course supposed to insert the string into the destination at this location, right? Well, that's pretty easy to do because we already know, and I suppose I could also do that advancing there. That's pretty easy to do because we know that we already have the ability to just kind of stream things out, right? We've got this outchar thing, oops, that I can use. So for example, what I could pretty easily here just go, okay, for char star, source equals string or something like this, star source, plus source, and for every character in the source, I'm just going to go ahead and output it to the destination, right? So that's a pretty easy, pretty straightforward version of the S code. Straightforward version, a pretty easy, so that's right. So that's a pretty easy, pretty straightforward version of the S code. And so if I run the game, well, I'd actually have to have the game running. There we go. So if I run the game now and we go to something that was S, an S-style thing, oops, I should be able to get it so that we can actually print one of those out. Of course, that should be one there, and I'm not getting it, so did I forget something? If at one, oh, I did. All right, so let's see. All right, so let's see what we get here. There we go. So in this case, we got a string. There's the string that we're looking for. I feel like this should work, right? I wonder if we probably need to support passing a null string here too, don't we? How are we doing on this? Chunk X. Here we go. So we copy that in there, and well, that looks fine. But for some reason, when we get to here, we're getting a string out. Oh, right. String out. Oh, string out. Right. So yeah, we have sort of another problem here that we're going to have to address, which is that since we're walking the stack, we have to pull out all the other things too. So I can't just pull out the S's unless I'm only printing out S's, if that makes sense. Because if someone has a %D on the stack there, I have to pull that one out or it won't work, right? Because since I'm reading the stack in order, if I just go look for a char star, because the only thing I'm looking for are %S's, that's not going to work. So I at least have to grab out the other kinds of values. Like I said, I want to start with just one so I can show you it working. So what I'm going to do instead of that is I'm just going to straight up break in the case where it's not a %s. So that way we're only dealing with things where they're %s as their first value, if that makes sense. Of course, I suppose we kind of still need some way of seeing the rest of the string. I'm trying to think of a good way to show this. Because then we won't see anything there. I guess I could do something like this. Parsing % is true. That way we'll skip anything that comes after. Okay. So let's see. Hopefully I should be able to find something that has a %s as its first thing. Well, I guess all of these guys do, right? So there you can see our %s working as we think. Well, I guess all of these guys do. So let's see. Hopefully I should be able to find something that has a %s as its first thing. Well, I guess all of these guys do, right? So there you can see our %s working as we had intended it to work. So, you know, you've got origin chunk and all that sort of stuff. So that's all fine. But you can kind of see that also we don't get any %print s's printing out when we are preceding them by something that we don't understand. And of course, the reason that happens is because, like I just said, since we have to, you know, the var_args function is pushing all of those things from the end of the function onto the stack in order, and we have to peel them off in order. If we don't, then we'll just get garbage, right? Because if we didn't peel off 1%d, so someone pushed an integer on, then they pushed a string pointer on. If we don't peel the integer off first, right, and advance by that much to get to the string, to get to the char star, we're just going to get garbage because we're going to read the integer as the char star, or as the first half of the char star, right? So we do have to be able to do that to make sure all of those work, right? Okay, so let's just try to take these in order now. You can see here that, You can see here that our first one is a %O2 FMS, a %DE, %DP, %DD, right? So in this format string, you know, these guys would be easy, the %D, 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 and the %O2 FMS, we can try to just like parse it. We won't print the floating point number yet, because I said that was the part that's hard that we'll have to save for a subsequent time. But we can sort of still hack it. Like, we still could sort of print it out in sort of a janky way, right? Or even if we don't print it out, we could still just peel, you know, advance the pointer properly so that we can still print out the rest of the things. All right, so I want to take a quick look to see what the actual spec is for Printf format specifiers, just because I don't know if they have to come in any particular order or what the rules are. I don't really know. So it looks like you can have flags that come first, and these are the flags. So a minus, a plus, a space, a pound, and a 0. And those are left justify instead of right justify. Force plus or minus for prepending, right? Space is to use blank spaces versus zeros, you know, so you can do spaces or zeros. And the number is, let's see, used with OX percentage different than 0. Different than 0. So I guess this one just does, okay. So we don't really care about most of these. We probably care only really about plus and 0. That's it. So we can just look for those two. I think that's the only things we really need to support for plus and 0 in the flags. Okay. So let's start with that. So we do parsing %, and we see that it's got a % here. And so then what we want to do is say, all right, and I can get rid of this now because we're going to actually grab everything. There we go. So what I want to do here is I want to now grab sort of all of the other things that I can grab. So width specifiers, all that sort of things. So first I could do, you know, if at 0 equals whatever we got here, I guess it was plus if at 0 equals, what's the other one I wanted to do? 0. So we kind of know some things here, which is force sign, pad with zeros. Pad with zeros is true. Force sign is true. So we can just kind of peel those two guys off. And again, I'm not doing anything particularly interesting here. This is just pretty ugly code, really. And I suppose I could sort of do this with a star for these guys because we're not sort of doing look ahead in this case. We're just, doing the very first thing we're looking at. So first we're just going to say, all right, handle the flags. And, for good measure, I suppose what we could do is accept but ignore other things as well. So, I could say, whatever this is, left justify. Right, and then I guess it's just space. And pound. What is it if no sign is going to return a blank space? So and finally we got pound. All right, so if I write it like this, right, and I'm just kind of putting this out here so you can kind of see it. What was this thing? This was like, annotate if not 0. So the problem with this is, right, like, I can't quite write it exactly this way because if I write it like this, they can only come in this specific order, which I don't really want them to, right? So sort of what I need instead is some way to kind of just sit in a little loop and read each one, individually, right? So I kind of need to do a thing where I'm more like, I don't know, something like parsing equals true while parsing, switch star at. And in here, I kind of need something that's more like, whatever I got. I'm going to put this here. So I can now say, and I could even kind of condense this up into something a little cleaner. Maybe like that. Right, so now I've kind of got this way of treating it like a little mini tiny parser, and that way they can go in whatever order they want. The user doesn't have to worry about which one they put first. I don't know if that's exactly the intention of the authors of the spec. I mean, Printf's not the most well thought through thing anyway. But, at least this way, I think the idea is that you're supposed to be able to put them in any order, so let's just support that and assume that that's true. So that seems reasonable to me. We come through here and we just kind of go like, okay, let's, keep reading flag specifiers, as many as we get. We've got force sign, pad 0, left justify, positive sign is blank. Annotate if not 0, and that's about it, right? Yeah. So then, I'm gonna put this up here as well. So then we'll come through, parsing, oops. So then we'll come through, parsing, oops, parsing equals true. We'll do the same thing for whatever comes after it. So let's see. We're supposed to have a flags field, then a width field, and the width field can be the minimum number of characters, right? So that's a number. or it can be a star. So it has to be one or the other, or nothing, right? So we can either get a number, a star, or nothing. So now we want to handle the width. So that doesn't really involve a parsing loop like that. That just involves reading as many numbers, if we have them, as we can read, or a star. So basically it's like, hey, if star at equals 0 at this point, I'm sorry, equals star at this point, then we're going to do plus plus at, and we're going to say that we need to read the width. And so the width itself, I don't really know what happens here, but I guess we'll say width specified equals false. And then we kind of need a thing that's like what the width actually is, right? And we'll just put 0 for now. So according to the spec, in this case, if there was a star as the width, we need to read the width out of the stream, right? So we know how to do that, right? We just do va arg, and we can say arg list, and then we just have to say, well, okay, if star is the thing, you know, if there's an integer coming out of here, then we need whatever the int is, and I want to put that into the width, and then we know the width was specified as a specific value, right? Otherwise, we want to see if you know, the star at sign is, you know, in between the numeric range. So if it is, then we've basically got a number that we want to read. So then we want to say that the width specified is true. And at that point, I feel like we have the notion in here somewhere that we can read values, right? We've got this S32 from Z kind of thing. So I should be able to just call this. Now, one thing that's kind of annoying about this is it doesn't tell us how far it read, right? So what we could do is we could also say S32 from Z. I should be able to just call this. We could say that this returns the value and the new at, right? I could do something like that. And that seems pretty compelling, because then I can make the old function, S32 from Z, where you pass in the at sign, and then I could do sort of like internal or something like this, like that, that returns a more complicated result. And so there we would have result.value would be the thing that's being tracked here. And when we get to the end, the result.newAt is going to be equal to whatever the at was. Then we return that result. So this function can just do call the internal one and just return the value. So that's all fine. But then, you know, down here where we actually care, we can just say like, oh, all right, there was a value that we wanted to read. So let's get the width by just saying S32 from Z, width read, S32 from Z internal, and I'll pass that at sign, and I'll say at, you know what else I could do? I could make this even simpler. I could just do, don't even bother with that, and just say this takes a pointer to an at, right? Because then I could just do like, all right, 32, like so. And this way we just write it back into here, and then this guy just says, well, all right, there's an ignored value. That, you know, it basically creates a little pointer that this guy will walk, and then we're all good, right? So that seems reasonable. That simplifies things a little. Don't care about that anymore. Okay. I guess we don't have a B32X in this code base, which is fine. So, now all I have to do is say, well, read the width and read it from this at, so that'll advance it, and then we know the width was specified, right? So that just eats up whatever the numbers were that came before it and treats those as the width, and then we consider the width to have been specified, and then we're good to go, right? So that seems pretty straightforward. Now we have to deal with the precision, which is a dot and then a number, or a dot and then a star. So it's essentially the same code as this, but it's just it's only if there is a dot preceding, right? So essentially what I want to do is say precision specified false, precision 0. I guess since these are technically S32s, I don't know what happens if you specify a negative width, but I guess we'll allow it for now, because I don't really know. Maybe that's when we read the spec, because it says an integer, so that's signed. So anyway, when we come through here, we go ahead and do the exact same code if there is a dot. So if star at equals dot, then we need to do the exact same code we have here. Like so. If it's a star, we read the precision. And if it's not, then we parse it out of the stream. We could also, since now we know here, if we see the dot, I think it has to be, we could say this is a malformed printf precision string, or a precision specifier. Just so the programmer knows that they probably messed something up, because if we see the dot, we know that there's really it's only allowed to be a star or a number. So at that point, we want to make sure we handle that. Okay, so now we've got precision in there. So finally, I think the only thing we need. After that is the actual specifiers, and there they are, right? There's D, U, O, X, F, E, G, A, C, S, P, N %, or whatever. Yeah. So let's see let's just take these one at a time. We'll just do a switch star at, and we'll do each of these. So case D or case I. These are apparently the same case according to the listing there. We've got a U. We have an O. X's. We've got F. Can't say I know what decimal floating point lowercase and decimal floating point uppercase mean, but I guess that means if you're going to print out a nan or qnan or inf, whether you wanted it upper or lowercase. Pretty impressive that they thought that was necessary to specify, but all right. No sense not dotting your T's, crossing your I's, and so on. So we've got E, G, and G. And then we've got A, and A. Hexadecimal floating point. I didn't know that was in there. I feel like that must be new, because I don't think that was there originally. S P N % and other. What is that thing called? Specifier. Unrecognized format specifier. So we've got one of these already, right? And I guess no matter what we do here, when we read this off, we're going to increment forwards, right? I guess the only case is if it was null, right? So if star at is valid, we'll advance by it. But if it was null, we don't want to read past the end of the string and confuse people with a crash or something like that. But yeah, in this case, we just go, all right, we've got a string that looks like that. So that one's done. And then we just have to implement all these other guys here. And like I said, we don't really have to implement them yet. We just have to make sure we're getting the right argument type off first, so that we can take them one at a time from there. So this is just going to be, right, an integer. That's what it's specified as being. So here's the value we're printing. In this case, it's going to be an unsigned integer. In this case, I don't know what an unsigned octal actually is, but I assume that this is always going to be a... I assume that these are always going to be integers unless we have instructions otherwise. But I feel like we could have instructions otherwise, couldn't we? Like, shouldn't there be like an L specifier or something? Like, there's nothing here that says that the thing is going to be long. Ah, there it is. Length. We forgot one. So where does that come? Flags with precision, length, and then specifier. Okay. So one more. Oops. So one more we got to do here. H, 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 L, 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 J, Z, T, and L. Boy, I feel like they could have done a better job with this. But all right. So it looks like... It looks like essentially the only thing you can do with floats is to make a long double, which I don't even support. So really, we don't care about that at all. So L is out. So it looks like we're mostly looking at H, 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 L. So I don't really care about most of these. So I think we'll probably take the same attack here. I'll read them all. But I don't think we're going to actually do any of them, except for L, which is if we want to say, like, you know, it's a long, a 64-bit value or whatever, right? Which I guess is LL in this case. Can't quite tell. So would an unsigned long int be 32 bits or 64 bits by this nomenclature? Right? Is that, you know, is that 64? Is that, I don't know. You gotta love that nonsense. But anyway, so if we want to handle the length here, really all we have to do is just take a look and see if we can match any of these things. So if star at equals, what do we got? I guess this one I'll do normal form because these are doubles. So if it's H, followed by another H, or an L followed by another L. Those are double character sequences. Everything else is single. So, all right. So we got H's, we got L's. We've got JZT, and capital L. And so, you know, yeah. In each of these cases, we're going to advance. I don't know which one of these we're going to handle in actuality. But yeah, so at that point, we need to be able to read these off. And if you look at what's happening here, really all of the, you know, we want to handle these guys in groups, because if we do end up specifying widths, these guys are easy because they're all specific to themselves, but these guys kind of happen in groups, so like we don't want to have to deal with a separate type of read code for all of this stuff, right? We want to be able to just read off the value using some kind of a width specifier that we make, right? So yeah, I don't know what to do about that exactly, other than probably something like do about that exact. I don't know. Yeah. So yeah, I don't know what to do about that exactly, other than probably something like. Excuse me. It's nose blowing time here on Handmade Hero. I guess what I'll do is just get kind of the largest possible value I can, and then we'll just you know, read var arg u64 or something like this. I don't know exactly what we'll call it. But what I want to do here is just say, like, okay, somebody has to use the width specifier at this point to figure out which one of these we're going to do. Because actually, we might read a U8, you know, or a U16, or a U32, or a U34 when we read one of these. So I guess we'll say read var arg integer, right? And we don't know which of those types of values we actually want, right? We have no idea. And I guess we could even pick whether we're doing signed or not. So we could do something like switch on length. And we'll just have to do something like this. And you can see that it's pretty ugly, right? It's the kind of code that C doesn't really make particularly easy to write, because it's still very procedural. It's still very clear how you would make this concise. But basically, you suddenly have to take like a leap into template land, and you can see that it's pretty ugly, right? It's the kind of code that C doesn't really make particularly easy to write, because it's still very procedural. It's still very clear how you would make this concise. But basically, you suddenly have to take like a leap into template land, and things go really horribly wrong when you go there. So there isn't really a whole lot you can do if you value, you know, any sort of semblance of working code in C to make things that are, you know, cleaner than something like this. But that's roughly it. So we could do something like, okay, pass the length and the arg list, and off we go, right? Now the arg list in this case. I think we would want it to be a pointer because we need it to advance. Unfortunately, that kind of means that we've got to do this little dance here where I have to dereference it so that their macro can re-reference it, which is kind of stupid, but I believe that's just what we're going to have to do because we want to use the arg list and advance it so that our parents gets it advanced, right? So this is essentially what we're looking at. You know, we've got a floating point version and a non-floating point version, right? And the floating point version really is only going to accept this so that our parents gets it advanced, right? So this is essentially what we're looking at. You know, we've got a floating point version and a non-floating point version, right? And the floating point version really is only going to accept two things, I suppose, because we don't really have a way to read anything else. If that makes sense. And also, I suppose I probably... Did I never do an F? I've recently... I don't think I ever mentioned this, but I've recently been less enamored with R, and I've switched to F. And the reason was because it sounds too much like red. When you use them in like things that are like packed value formats, it tends to get confused with the red channel, I find. Whereas F doesn't really get confused with anything. So I've kind of changed my feelings on that. Anyway, so now we can kind of do these guys a little bit differently. We could say here, like, okay, so they're... So now we can kind of do these guys a little bit differently. We could say here, like, okay, so there's a value that we're reading, and it's read vararg float or integer, depending on which one we want, and we need to pass the length thing to it. Length, or I don't know what we'll call this. I'm just going to call it len. So this will be u32 len equals... I guess the default len is just always 4 in... Well, you know what? We've got 2, I guess. We have integer len and float length. Because the default float length is 8, and the default integer length is 4. So yeah, so then we can just kind of go in through here and say, all right, if I'm doing a float, like it would be in, say, this case, I just do float length, arg list, and I can grab that. And so all these guys can do that read, and you know what? This has to be an address as well. And I think that's all of those. So that will get all of those guys out. Then we have our integers. Read our integer. Integer length. There we go. And I don't know what we're going to have to do about the sign extension sort of stuff there, so we'll take a look at that in a second. Because really, so when we do reading the integer and we get the U64 out, we should be able to just kind of cast it slyly to another one. So I could do, you know, unsigned integer, and then have another one that's just like signed, and it just does, you know, unsigned. The U64 out, we should be able to just kind of cast it slyly to another one. So I could do, you know, unsigned, you know, unsigned, you know, unsigned integer, and then have another one that's just like signed, and it just does read vararg unsigned integer. And we'll just pretend that value that we read was actually a signed value. Because when we read it off the list, right, it doesn't know what it is, so it just casts it to that and sticks it in the value. So when it comes out, if it was signed, well, the value is still correct for the signed value. It just C thinks it's the wrong thing. So all we really have to do is tell C, hey, by the way, that value was actually signed, so, you know, just chill out, man. And off you go. So that should be fine. So this should be signed. So this should be signed integer. And this should be unsigned integer. Right? And then for the rest of these guys, I think they're all unsigned, right? I don't think X is... I don't think X is... or any of these guys... Oh, these are floats. Never mind. These guys are floats. C is just a char, I think, right? So I don't... Is there anything you can do with C? Oh, you can get a W int T out of it. So I guess we still have to sort of maybe a little bit... I don't know whether this means I should still read it or whether it's an error, because like there's nothing in the table here, so I'm not sure what they actually want you to do. There? And in either case, it reads the same size, right? Like, what's a W int T? Is that actually bigger? Type def of a type %, any char. So yeah, so I don't think that's... So I don't know exactly what we should be doing there, to be honest with you. Dude, how much are we supposed to read here? Right? Like, what's it actually needed, or whether I don't care. These guys, or any of these, I think they're all. So tell C, hey, by the way, that value was actually signed, so you know, just chill out, man, and off you go. So that should be fine. So this should be signed. So this should be signed integer. And this should be unsigned integer, right? And then for the rest of these guys, I think they're all unsigned, right? I don't think X is... I don't think X is... or any of these guys... Oh, these are floats. Never mind. These guys are floats. C is just a char, I think, right? So I don't... Is there anything you can do with C? Oh, you can get a W int T out of it. So I guess we still have to sort of maybe a little bit... I don't know whether this means I should still read it or whether it's an error, because like there's nothing in the table here, so I'm not sure what they actually want you to do. There? And in either case, it reads the same size, right? Like, what's a W int T? Is that actually bigger? Type def of a type %, any char. So yeah, so I don't think that's... So I don't know exactly what we should be doing there, to be honest with you. Dude, how much are we supposed to read here? So anyway, keep on going here. I think I've got a little time left anyway because I started about 10 minutes late. Anyway, so we'll read that value out there. And then we've got the p, n, and %. The % case, we don't read anything off the stream. That's just the case where we output, like if someone was actually just trying to output %, right? Straight up. The p case is what? A pointer address. So that's still going to be the same kind of a read, I suspect. Although, does that mean we always would read a pointer size? Yeah, it looks like it's always a void star. So basically, that's another one that always comes out the same size no matter what. And then the N is when we write the number of characters written so far. So basically, this is going to be a pointer to a signed integer. So, you know, this is basically a destination, like a tab dest or something. This is if we want to know how many we printed. I don't know that we use that anywhere either, but we might as well parse it properly. We can always choose not to support, you know, any of these we don't feel like writing, but you know. So in this case, we grab an int out. I guess we should keep the int value even though we're only supposed to process it as a C, but let's go ahead and start running it. I don't know how disastrous this is going to. Let's go ahead and start running it, but I guess we should keep the int value even though we're only supposed to process it as a C, but let's go ahead and start running it. I don't know how disastrous this. Let's go ahead and start running it. I don't know how disastrous this is going to be, but we'll see. So let's take a look here. Where are we at? We've got a dot on here. Let's step through this code at least once because I don't even know what's going on here. Okay. So first we want to take a look. We've got a .02f specifier. So that means there's nothing in here, right? Which is good. So we just skip over the flags because there's no flags. We then have to handle the width, and there's no width either, so we skip that. We got a precision, so then we look to see whether it's a star. It's not a star. We look to see if it's a number. Oh, there we go. We're missing a little plus. We need to consume that plus. I mean that dot, rather. So that's all good. Yeah. And in this case, we still have a to-do here, right? Which is to do actually set different values. So that's all good. I mean that dot, rather. So that's all. We need to consume that plus. We're missing a little plus. We're missing a little plus. We need to consume that plus. I mean that dot, rather. So that's all good. Yeah. And in this case, we still have a to-do here, right? Which is to do actually set different values here, which we're not doing. Okay. All right. So I think, let's see here. We're getting there. Unrecognized format specifier. Which is what? What was the string that we were passed? %02.02f. Unrecognized format specifier. 2f %%. I feel like that should have worked. So that is a bug. That is not a malformed specifier. Let's try that again. I want to... Nope, that's not what I wanted. Can you show me? Thank you. I would like to go ahead, and I'm going to kind of cheat here a little bit because I want to debug that one case. What I'd like to do here is just sort of fake it. I'm going to basically say that instead of every time you call format string, I'm actually just going to like pretend that that's actually the string that we were given, right? So I'm going to say like, you know, format string. Well, you know what? I don't even have to do that. I'll just put this at the very start. So here's game update and render. And I'm just going to go ahead and put it right here. And so that just takes a floating point number, but that's it. So I should be able to just pass it a 1. Okay. So let's go ahead and compile that. And now, in theory, the first time I come through here should hit that, right? I should get that case, and I do. So let's see what I do. I'm going to jump forwards to where we actually hit the format specifier. Let's see what we get here. So there's a 0. We get pad with zeros. That does seem a good idea. We then don't get anything else, and that's what we would expect. We come down here. We don't see a star for the width, but we should see a 2. So let's advance that. We did, and the width is 2. That's what we want. The width has now been specified. We look at the precision specifiers. The precision specifier says there's a dot. There is a dot. We advance forward. We take a look. It's not a star. It is, however, a number. Well, okay. So actually, it seems like we're missing. There should have been recognition of the fact that there was a leading 0 as a separate thing. So I kind of have to fix that as well. But let me just go see what the other problem is here. So it goes and grabs the F off of here. There it is. And, you know, these guys don't advance their letter at the moment, which they should. Now, it's unclear whether we want to go through here and advance every single one of this letter, or whether we just want to have someone who's not supposed to advance back up. But I don't even know if that's relevant. Oh, wait. No, we actually did. We did do that, didn't we? No, I guess in all cases we don't. I thought I did it like if at. So I must have accidentally deleted it, because they're going to say we used to do it, right? So after that, I just want to say if start. So after that, I just want to say if start, plus plus at. I accidentally deleted that, I guess. Okay, so let's try that one more time and watch what happens in the. Oh, and you know what? I want to fix that one other thing first. So in this case, what I really want to say is if it's a star, okay, it's a star, that's all good. But then we should have had, so after that, I just want to say if start, plus plus at. I accidentally deleted that, I guess. Okay, so let's try that one more time and watch what happens in the, oh, and you know what, I want to fix that one other thing first. So in this case, what I really want to say is if it's a star, okay, it's a star, that's all good. But then we should have had, let's something in here. Let's see. I feel like it's not. So after that, I just want to say if start, plus plus at. I accidentally deleted. I feel like it's not really documented, the .0 part. Like, it doesn't really say anything about that. The value to be written is short of this number. The result is padded with leading zeros. So does that mean 0.02 is not really a valid formed string and it shouldn't? Huh. All right. I guess maybe my 0.02 is not even really... Should it just be 0.2? I don't know. All right. Well, I guess I don't have to fix that then. Back to the debugging. So let's take a look at what happens in here. First time through. So we get down to here. So let's take a look at what happens in here. First time through. So we get down to here. And we're at the %f thing. We advance forward. So now we come through here. What happens? Well, we skip the %. All of these... Oops. That's not what I wanted. Okay. We skip all of these because none of them should be there, so I'm just going to verify that they're actually skipped, because maybe one of them isn't skipped or something like this. None of that happens. We then do a switch. We find the %, and that's good. And we advance. So I think now it was just the fact that I accidentally deleted the advance. I think that was the only problem. So now I think we're all good. And yeah, this looks much better now. Okay. So I think we've essentially set ourselves up for success now. We just have to do a couple printout routines. Those will... so let's take a look at what happened. And those will be real easy to do, probably, I think, except for the floating point one, like I said. But everything else looks like it's in reasonable shape. So I'm going to go ahead and remove that test code here, since it's no longer necessary. And then I'm going to go to Q&A. Q&A. Not a lot of questions, which makes sense. It's pretty straightforward. Duplicating printf is just kind of busy work for the most part. Soy sauce the kid, will you be doing a sprintf? It is a sprintf. That is sprintf. That's what we just wrote. I mean, that's printf right there, right? Is the GitHub repo accessible to pre-orders? Yes, it is. It's not really a supported feature, so no guarantees that, you know, it'll work for you or whatever, but every pre-order does come with the code, because people wanted it, come with a code that allows them to authorize on the GitHub. So it's not an official feature of pre-ordering, but it is actually available to everyone who pre-orders. I just don't support it. Like, if you screw up and authorize the wrong username, you're on your own. Like, I'm not even going to look at it. So it's not an officially supported part of pre-ordering. Whereas if you, like, can't download the source code for some reason from the normal Sendal supported thing, I go and find out why and help you.